Okay, so let's go ahead and start looking at a few of the examples. So number one, the first thing that you need to do is to make sure that you actually have a difference of squares. So we check to make sure that there's two terms. Do I have two terms? One, two. Two terms, check. Okay. We also need to check that it's a subtraction. Okay. Subtraction. And yeah, it is. Check. The next thing we need to check is that both terms are squares. Okay. Meaning that you can see an exponent of a 2. Okay, that's what we need to do. So with my first term, it's very obvious that it's a square. It says a squared. You see that little 2 up there. Perfect. But with my second term, 4, I don't see that. I don't have a squared. But can't 4 be written as a square? Can't you write 4 as 2 squared? Okay, it's the same exact thing. So we have, instead of saying a squared minus 4, I'm going to say that I have, and I'm going to do a little color coding here, a squared minus 2 squared. Okay. And the reason I'm going to do a little color coding is that whenever we factor, we're going to use this formula, okay? This rule. So since everything, all my criterias are met, I get to factor this by using the differences of squares. So what I want you to do is once you have it written so that both terms are squares, you write an equal sign, equals, and then you write two sets of parentheses, okay? Just fill them in right there. And then the first set, you're gonna have a plus sign, and then the second, you're gonna have a minus. Now, what do you put in both of those? Well, if you notice, you've got the A, okay? You have the A right here, which in this expression, it's still just A, okay? And then our B, or our second term, is the 2, okay? Now you notice I didn't put the squareds anymore, okay? We're just talking about carrying those bases, using those bases to fill those in. So how do you factor a squared minus 2 squared? It's the quantity a plus 2 times a minus 2. Okay, so let's look at the next guy. So first thing you want to see is, do you have a difference of squares? So you need two terms, check. You need a subtraction, check. You also need both of the terms to be written as a squared. Well, the first term, n squared, that's easy to see, okay? But 64, that doesn't have a squared. But can you rewrite it so that it is? Okay, is 64 a perfect square? Yeah, because 8 squared is equal to 64. So all I did was rewrite that second term so that you see the exponent, okay? So that it's very clear what is the base, what is the exponent. Now I can factor, okay? And I do it the same way. I always set up my parentheses, and this is a plus sign, this is a minus sign, okay? And so it factors into a plus b, a minus b. Here your a is n plus, what is your B term? 8. N plus 8, N minus 8, okay? And so if you're uncertain about this, check and see if this works out, okay? Go back the other way, distribute and check your answer. See if after you're done distributing this, do you end up back with n squared minus 64? And you will, okay? All right, number 3, don't let it get you fooled that the variable is in the second term. That's okay. Here, I'm going to have 81 is the same as saying 9 squared, right? Minus x squared, okay? So I always like to take the time to rewrite it. All right, and now this is going to be equal to, I'm going to draw my two sets of parentheses, my plus sign and my minus sign. Okay, my first term is 9. Okay. And then my second term is x. So do you see how I'm just kind of filling them in? So just be very systematic about it and always do it in the same way, okay? All right. So I'm gonna let you do number 4 and number 5, okay? Let's look at number 6. Okay, so this one, we want to check and see, do we have two terms? Yes, we do. Okay, and then is it a minus? Yes, it is. So from there, we need to check and make sure each term is a square. Okay, now the first one, what is one as a square? Well, one times one is one, right? So one is the same thing as saying one squared minus. Now, you got to be careful. This term almost looks like it's a squared, right? Because you see that little 2. But that little 2 is directly above just the y. That term is not being squared. Just part of it is. 49 is not being squared. That's a problem. You need to make sure that your whole entire term is written as a square. But there's a fix that you can do with that. 49 is the same thing as 7 squared, right? 49 is the same thing as saying 7 squared. So instead of saying 49y squared, I'm going to rewrite it. I'm going to have my black. Okay. I'm going to rewrite it so that the whole term is being squared, so that I'll have 7y squared. Okay, so you need to make sure that the whole term is being squared, not only the variable, but the coefficient as well. Okay, so now that we have two terms, there's a subtraction, and they're both written as a squared, I can factor. Okay, put the plus, the minus, so I have the first term, which is 1, plus the second term, which this time it's 7y, okay, times the first term minus the second term, okay, and we are factored. If you don't believe me, go ahead and distribute and see if you arrive at the original expression. Okay, let's do one more just like that one. Okay, so I have 9b squared minus 100. So it's very clear that there's two terms and there's a subtraction, but neither term, as they are now, are written as squareds. Okay, this 9b squared, the b is being squared, but the 9 is not. You need to rewrite it so that the whole term is being squared. 9 is the same thing as saying 3 squared, so we'll write it as 3b squared. Oops. 3b squared minus, well, what's 100 squared? What's 100 written as a square? 10 squared. Okay, so now we have the difference of squares, which is very obvious. So I'm going to factor, I'm going to draw my two sets of parentheses. I'm going to have a binomial. One of them is going to be a positive and one of them is be a minus. Okay, so I have the first term, which is 3b, plus the second term, which is 10, times the quantity of the first term, 3b, minus the second term, which is 10. Okay, all right, so I'm going to leave number 8 and 9 for you. All right, let's look at 10. Right now, I have an x squared minus an 81y squared. So it's very obvious that I have two terms. There's a subtraction, but they're both of the terms, the way they are not written as a squared. The first one is you have x squared minus, well, instead of 81y squared, we need to make sure that coefficient is a squared as well. 9 times 9 is 81, so we'll rewrite 81 as 9 squared. Okay, we'll make sure that the coefficient and the variable are being squared. So now you have two terms being subtracted and they're both squares, so you can factor using the differences of squares. One has a plus, one has a minus, and then I just fill in from there. I have x plus 9y times the quantity x minus 9y. Okay, so you just kind of fill them in once you have it written. So one of the hardest parts is that checking to make sure that each term is truly written as a squared. Okay, so here on number 11, okay, And I'm gonna just start using all the same color to help myself out, okay? Um, they're not written as squares yet, but I can write 4h squared as the quantity 2h all being squared, and then 25g squared as the quantity 5g squared. Okay, so now that you have the differences of squares, you can write two binomials, okay, where we have the first term, 2h, plus the second term, 5y. You notice, guys, these squares are not coming along to your final factored form, okay? And then we have 2h minus 5g. Okay, I'm gonna let you guys do number 12. Okay, so let's look at 13. So x squared y squared. This one looks a little bit confusing, maybe right off the top. What is your actual base? How can you rewrite that so that it's just a single square? Well, x squared y squared, if we remember the property of exponents, that if you have a product, okay, with a squared written above it, you can distribute it so that it's x squared y squared. Okay, so whenever you're simplifying, it's ideal to have it written like this. But now that we're factoring, it's going to be ideal to have it written like that. So x squared y squared is the same thing as xy squared. Minus, what is 1 written as a square? Just 1 squared. 1 times 1 is 1, so nothing changed there. So now that we have the differences of squares, I'll set up my parentheses. One's a plus, one's a minus. The first term is xy. The second term is 1. Okay, and we'll just fill those in. Okay, so I'm going to let you guys do number 14. Let's look at 15, guys. 15, you have two terms. There's a subtraction. And the first term can clearly be written as a square. But can you write 5d squared as a perfect square with whole numbers? Nothing times itself gives me 5. So this cannot be written as a square. So what would we call this expression? When we can't factor it, it's called prime. Okay, and so we've got a prime example right there of a prime expression. Okay, so 16, let's see if we can do this. 49m to the fourth. Oh, I've never seen this before. To the fourth, we need it written to a squared power. Is that going to affect how we do this? Let's see. Well, 49 squared is, or 49 is the same thing as saying 7 squared, right? And m to the fourth is the same thing as saying m squared to the squared. Okay, so I rewrote it. So what I did was I kind of did the your exponent rule, okay, in reverse. Okay, when you have exponents raised to another exponent, you have to multiply them together, right? So I rewrote it so that it I pulled it out. So I know that my term, my base is 7m squared. Okay, minus 16 is the same as 4 squared. So let's go ahead and do this. What is my first term? My first term is everything inside that parentheses. 7m squared plus 4, 7m squared minus 4. So that one was a little trickier for sure. K to the 6th. How do you think we can write that as a square? Think of the power to a power rule, okay? When you have a power to a power, you multiply them together. So k to the 6th could also be written as k to the 3rd raised to the 2nd. So now your term, your base to your squared is k to the 3rd minus 4 squared again. So my first term is k cubed minus or plus 4, and then k cubed minus 4. Okay, so I'm going to go ahead and leave 18, 19, and 20 for you. And we're going to work out the next examples in the next video.